Hello everyone and welcome to a new lecture. So right here we're gonna see how we can find the equation of a tangent line. So suppose we have a function like that, okay? Basically, if you choose a point, then we want to find the equation of that line, okay, that is tangent to the function at that particular point, okay? And the reason we are talking about this because the tangent line or the slope of the tangent line at a particular point, that is the derivative of a function. Okay, that is what we've been talking about it so far. Okay, so we're gonna use that idea, the slope of the tangent line, in order to find the equation of the tangent line. Okay, and what is the equation of the tangent line? Well, basically it is y minus y1 equals to f prime of x multiplied by x minus x1. These y1 and x1, these are the y and x, or x and y coordinate of your point, okay? So this is x1 and y1. This point right here, it has a coordinate of x1 and y1. This f prime of x, usually they write m right here, okay? M is the slope. But since the slope is just f prime of x is the derivative of the function at that particular point, then we're just gonna write f prime of x, okay? So let me give you an example and let's see how we can find the equation of a tangent line to a particular function at a particular point. So example 1. Suppose I have f of x to equal to x to the 2 plus 3x minus 1. And I want to find the equation of the tangent line at 0 and minus 1. So it's very, very easy. Just plug in everything that you have right here into this equation and you'll find the equation of the tangent line. So first of all, let's write f prime of x. F prime of x is the slope of the function, and if you evaluate it right here, then it is the slope of the function at that particular point, and that is exactly what we want. So f prime of x actually equals to 2x plus 3. Okay, what is f prime of? So I want to find it at this point. So if I plug in this x, okay, I can get the slope at that particular point. So from this, f prime of 0 actually equals to 3. That is my slope at that particular point for this particular function. So I have the slope, I have f prime of x, I have y1, I have x1. I can find the equation of the tangent line. So y minus y1 is minus 1. We have a minus right here, so it will be plus 1 equals to 3 multiplied by x minus 0, because x1 is just 0. So this is x1, this is y1. Okay, so from this, y plus 1 actually equals to 3x, and from this, y equals to 3x minus 1. That is the equation of the tangent line at 0 and minus 1 for this particular function, x to the 2 plus 3x minus 1. Okay, as you can see, it is very, very easy. All you have to do is just to memorize this equation, and that will be it. And this thing right here, this is just f prime of x. When you find f prime of x, evaluate the x coordinate of your point into f prime of x. That will give you the slope at that particular point. If you have the slope, you have the y coordinate, you have the x coordinate, plug it in into this equation, and you'll get the equation of the tangent line. Okay? So let me delete all this and let me give you another example. So example 2. Suppose I have, so let me delete this one too. Suppose I have f of x to equal to a rational function. So we have x minus 1 right here. Okay, and we have x to the 2 plus 8 right here, and I'm going to find the equation of the tangent line for this particular function at 1 and 0. So first of all, what I'm going to do, I'm going to find f prime of x. So f prime of x actually equals to, so this is a rational function. It is the denominator squared, so x to the 2 plus 8 to the 2, okay, and then the derivative of top is just 1 multiplied by the bottom. It is x to the 2 plus 8 minus, okay, the derivative of the bottom, which is 2x multiplied by x minus 1. Okay, so it equals to x to the 2 plus 8 minus, okay, 2x to the 2 minus 2x over x to the 2 plus 8 to the 2. Okay? So, if I evaluate f prime of 1, actually this will equal to 1 plus 8, which equals to 9, minus 2 times 1 is 2, minus 2 times 1 is 2, so this will be 0, so we will have 9 right here. And in the bottom we will have 1 plus 8 is 9, 9 to the 2 is 81, which equals to 1 over 9. That is our slope at that particular point for this particular function. Now we can find the equation of the tangent line. So basically y minus y1 is 0. Okay, so this is x1, this is y1. Equals to 1 over 9 multiplied by x minus 1. Okay, so from this, y equaling to x minus 1 over 9, this is the equation of the tangent line. Okay, let me give you the last example. So let's delete this. F of x equaling to, so the natural log of x plus 1, okay, find the equation of the tangent line of this particular function at 0 and 0. So this is example 3. So what is f prime of x? Well, f prime of x actually equals to, so this is natural log of x plus 1. Basically the derivative of that is just 1 over x plus 1. Okay, and if you evaluate at 0, if you evaluate this derivative at 0, basically equal to 1. So this is our m. So y minus 0 equals to x minus 0. So from this, y equaling to x, that is the derivative, or that is the equation of the tangent line for the function natural log of x plus 1 at 0 and 0. Okay, so basically that is how we find equation of tangent line. Okay, and attached to this lecture there is a document containing practice problems. Just download it and practice this concept. Okay, so with this we come to the end of this lecture.